right, let's get going again on some more examples. So what I'll do for these is just kind of the same procedure. I'm going to go ahead and list the circuit, what we're going to look for, and then we're going to go through and solve all these guys. I'm not going to go through each individual of these and go through the Kirchhoff's voltage loop. You can go through those on your equation, or I mean on your own, and just refer back to the first video about series circuits, or I guess the second video, I guess I should say, the main lecture part, to going through with how to solve for it. All right, so for the first circuit that we're going to have, it is going to be this. So we have our AC generator, we have our capacitor, and we have a resistor. So capacitor 1 is going to be 390 nanofarads. R1 is going to be 200 ohms. We're going to be working at 15 volts peak and at 380 hertz. So given our circuit, these are the parameters we want to find. Our X of CT kiloohms at an angle. Our impedance total is going to be in kiloohms at an angle. Our I total is going to be in milliamps with its angle. VC1 is equal to volts. VC2 is equal to volts, and these are both at angles. So with this example, what I would suggest is to go through and try and solve it yourself first. Pause the video, stop it, whatever you need to do, and then go through and with the explanation, see where you went. Like I said, I'm trying to go step by step, so if you do have any mistakes or errors that you can catch them. And again, feel free to reach out to me with any questions that you have. All right, let's go ahead and start solving this. So the first thing we're going to look for is the capacitive reactance of capacitor 1. Its associated formula is 2 pi, or 1 over 2 pi Fc. So X of C1 is 1 over 2 pi times 380 times our capacitance, which is 390 nano. The capacitive reactance of C1 is equal to 1.074 K at negative 90 degrees. Now we want to go through and we want to solve for our impedance total. And that, quite simply, is going to be 200 minus J 1.074 K. Now, once we have that in rectangular, we need to convert it into polar so we can be able to divide it to find our current to use that to solve for our voltages. So again, we take this and convert this guy into polar. The magnitude is going to be equal to 200 squared plus 1074 squared, square root of that answer. The magnitude is equal to 1092. The phase angle is equal to the arctangent of negative 1074 divided by 200, and our phase angle is equal to negative 79.451 degrees. So our impedance total is equal to 1092 at an angle of negative 79.451 degrees. Moving forward, we're going to solve for our current total, and that's going to be by our 15 volts at 0 divided by the 1092 at negative 79,451. That is going to equal 13.0 0.736 milliamps peak at 79.451 degrees. Now that we have our current, we can go through and we can solve for the voltages. So the voltage across capacitor 1 is equal to 13.736 milliamps at an angle of 79.451 degrees. And that is multiplied by its reactance, which is 1074 at negative 90. Voltage of capacitor 1 is equal to 14.753 volts peak at an angle of negative 10.549 degrees. The voltage of resistor 1 is equal to 13.736 milliamps at an angle of 79.451 degrees multiplied by the resistance of 200 ohms at 0 degrees. Voltage of resistor 1 is equal to 2.747 volts peak at an angle of 79.451 degrees. Now again, just looking at these guys, we have 79.451 degrees and negative 10. Those are, in fact, there's a delta of 90 degrees between them. So with that, our calculations at least should be good because the angles match up. Now we can always go back through and double check using Kirchhoff's voltage loop. And we convert these guys into the rectangular forms and then add them together. And doing that, we should be able to achieve our final result of 15 volts at 0 degrees is where it should end up. And like I said, I'm not going to go through that on these ones, but you can in your practice and verify that the numbers you got equal those values. So there is that circuit solved out with the values that we're looking for. The reactance total, the impedance total, we have our current total, we have the voltage across capacitor 1, and we have our voltage drop across resistor 1. So with that, that equation is solved and that circuit is done. We can go back through and we'd fill back in the table and list out all the values for this as we go. But again, like I said, we'll have it in our notes. We'll have these videos. If you have any questions, please again, feel free to contact me at any point and I will answer them and get you guys going on the right track. All right, let's move on to another circuit. Again, I will give you a chance to, I'll pause for a second to give you a chance to work the problem, pause the video, work it through, and then go through with your values and double check against what the answers are. So our next circuit, we will have a single resistor and a single capacitor. We have 39 nanofarads. We have 130 ohms. And our voltage supply, 20 volts peak and 6.66 kHz. And yes, I know, I did that on purpose. Things we want to find. The X of C total, our Z total, I total, VC1, and VR1. Now our reactance total is going to be in terms of ohms at an angle. Impedance total is ohms at an angle. I total is milliamps at an angle. Volts and volts. Okay, like I said before, go through, solve these equations by yourself, pause the video, and then we'll go through the explanation on how to solve all these guys. Let's go through and solve this. The capacitive reactance, 1 over 2 pi FC. So the reactance of the capacitor is equal to 1 over 2 pi times 6,660 hertz and the capacitance of 39 nanofarads. The reactance is equal to 612,747 at negative 90. Now the Z total that we have is going to be equal to the 130 ohm resistor minus J of 612.747. We're going to need this value in polar because we're going to find current with it. So this value we need to convert, and if we look at our answers, what we're trying to find, our impedance total we want in polar notation as indicated above. So we have to convert this thing through polar. Which is the 130 squared plus the 612,747 squared. Square root of that is equal to the magnitude. The magnitude of that is equal to 626,386. And to find theta, the arctangent of negative 612,747 divided by 130, and that angle comes out to be negative 78.022 degrees. So there's our impedance total. Now we want to solve for our current total. So voltage total divided by impedance total. So we have 20 volts at 0 degrees divided by 626,386 at negative 78.022 degrees. I total is equal to 31.929 milliamps at an angle of 78.022 degrees. Now we use that information again to solve for our voltages. So the voltage drop across capacitor 1 is equal to 31.929 milliamps at an angle of 78.022, and that is multiplied by the reactive capacitive reactance of 612.747 at an angle of negative 90 degrees. Voltage of capacitor 1 is equal to 19.564 volts at negative 11.978 degrees. Voltage of resistor 1 is equal to the current through it, which is 3.929 milliamps at 78.022 multiplied by 130 at 0. Voltage of resistor 1 is equal to 4.151 volts at an angle of 78.022 degrees. And that is our answer. Again, remember, we could have a little bit of variation depending on how your calculator is set up to round. And again, as long as we're within 5 to 10%, everything is fine. The last equation I have for series circuits is we're going to add more resistance to it. So now we have two resistors. So we're going to have R1, capacitor 1, and resistor 2 connected up to our AC source. R1 is 175 ohms. R2 is 310 ohms. and capacitor 1 is equal to 300 nanofarads. The voltage that we have is 10 volts peak, and we have at a frequency at 400 hertz. And the things we're looking for, again, is going to be the standard. We're looking for our capacitive reactance total, and that's going to be in kiloohms at an angle. Our impedance total is going to be in kiloohms at an angle. We're looking for our I total in milliamps and its angle. And the voltage drop across R1, voltage drop across R2, and the voltage drop across capacitor 1, not 3, 1. And these are all in volts with its associated angles. Again, pause the video, work through it, and then we'll go through the answers. Capacitive reactance for capacitor 1 is equal to 1 over 2 pi times the frequency times capacitor 1's capacitance value. X of C1 is equal to 1 over 2 pi times 400 times 300 nano. X of C1, the capacitive reactance, is equal to 1.326 kiloohms at negative 90 degrees. Our impedance total is going to be equal to the sum of all the resistance and all the capacitive reactance in the circuit. So it's 175 plus 1.3, or plus, sorry, let me start that over. Our impedance total is 175 ohms with no imaginary component, minus J, because it's a capacitor, of 1.326K, and then we have another 310. So again, the capacitor has no resistive component, and the resistor has no capacitive or reactive component. So this is how it's going to go. We add like terms together. So our Z total in rectangular form is going to be 485 minus J of 1.326K. Now we need to convert this guy into polar, because for one, our answer is asking for it in that format, but also we need it in polar form to be able to do the calculations to solve for our current. So we're going to convert that to polar. So the Z total is going to be equal to 485 squared plus 1326 squared, square root, at an angle of the arctangent of negative 1326 divided by 485. The final value we run into is 1.412K at an angle of negative 69.909 degrees. Now we solve for our I total. 10 volts peak at 0 divided by our impedance total, which is 1412 at an angle of negative 69.909. That gives us 7.082 milliamps at an angle of 69.909 degrees. VR1 is the current going through it times the resistance, which in this case it's a series circuit, so all of it's going through it. So 7.082 milliamps at an angle of 69.909 multiplied by 175 at 0. VR1 is equal to 1.239 volts at an angle of 69.909 degrees. VR2 again has the same current, So 7.082 milliamps at an angle of 69.909 multiplied by 310 at 0, and VR2 is equal to 2.195 volts at an angle of 69.909 degrees. Voltage across capacitor 1 is equal to the 7.082 milliamps at an angle of 69.909 multiplied by the capacitive reactance, which is 1326 at a negative 90. Voltage of capacitor 1 is equal to 9.391 at an angle of negative 20.091 degrees. And there it is. So we have three circuits that we can solve for, and in this equation, those are our answers. Again, if you do need some help, you can always rewind to them. I'm going to leave those answers there for a second. They will also be in the notes on OneNote as well that you guys can go through and look at. Again, if you're having problem accessing those, please let me know. If we have to, we'll figure out something where we can have you guys come in. We can do appointments one-on-one. But again, we'll be maintaining the 6-foot distance. We won't be coming close to each other. If you're feeling sick or things like that, we won't do it. But just remember that I'm here for you guys, and I want you guys to succeed. Please, 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 if you do have questions, let me know. Call me, text me, email me. If you have to, take a screenshot of your work and send it to me. I can go through it then with you, and then we can figure out where the problem is or where you're going wrong. Also, when you're getting through these, this will take care of the equations and the problems for online. Oops. Apparently you guys are looking at Star Wars events. Let's see, let me just load up let me load up Moodle. So again, we're in topic 2. And so that's going to take care of the series RC circuits. We're going to work on the parallel RC next in the next video, and then the series parallel after that. Again, as we go through these, just remember, if you guys, any questions you have whatsoever, please, please, please feel free to reach out. I will be available to help you out with whatever we need. And if I need to, we'll get on either some sort of video chat that we can discuss, and we can share answers back and forth. If we use Zoom, you can pull up your OneNote and have that sitting in the background, and then as we're working problems, we can write back and forth and actually look at each other and see what they're doing, what each other's work is. It's one of the cool things about that is you can share things back and forth. But again, like I said, those are 3 examples. The quiz is available. You can go through those, and it's the same format as before. You'll have unlimited attempts, highest grade counts. You have to get an 80 on them. And we will have a test at the end of the week on Friday. That it'll, you can take it whenever, but work on it through Friday through Sunday night. It has to be done in then. There is options for extra credit for getting it done early on time or earlier by like Friday, and also an extra credit problem that you guys will have afterwards. Again, it's just going to function just like regular classes, but just please remember that we do have these deadlines. Don't wait till the last minute. Watch these videos, do what you need to do, and get yourself to the point where you can pass the quizzes without any problem. Or if you do need help, like I said, please feel free and reach out. I'm here to help you guys. Okay, the next video we're going to have is going to cover parallel RC circuits.